All right, homework 4.8, we've got some average value mixed together with some fundamental theorem of calculus stuff. It looks like we've got a bunch of stuff we've done on here. I'd like to do number 2 to make sure we know our average value all the way. The average value of this function is the integral from 2 to 5 of that function divided by 5 minus 2. So let's do this integral. It's going to be the antiderivative, x cubed plus x, evaluated from 2 to 5. I'm going to put in this divided by 5 minus 2 at the end to save me some room. This means we plug in 5, so we get 125 plus 5 minus, we get when we plug in 2, 8 plus 2. So we get 130 minus 10, which is 120. That's this integral. That's the total area of this function divided by the width tells us that the average value is 40. All right. So number 6, here's a fundamental theorem of calculus question. So here we're looking for f of x is equal to the integral from a to x squared of sine of t cubed. Then f prime of x equals, all right, so f of x says we're supposed to do this integral. And then we're going to be taking the derivative of it. So this is the second fundamental theorem of calculus. This is actually an impossible integral to do. There's no way to do this integral. And so we can't do it, but we can imagine. This has some antiderivative, right? F of x is the integral of this guy, right? And so when we do the antiderivative of this, we're going to evaluate it from a to x squared, right? I guess this was t. It's going to be f of t evaluated from a to x squared. And so we get this f of x squared minus f of a. That's what f of x is, right? We do this integral, we plug in x squared, we plug in a, and subtract them. So when we take the derivative, well, we're going to be taking the derivative of the antiderivative of this, so we'll get right back to this. This is going to be sine of x squared, sine of t, yeah, sine of x squared cubed, because x squared is going to be there where t is, times, by the chain rule, times the derivative of x squared, which is 2x. This one, when we take the derivative f of a, when you plug in a constant into the antiderivative, will just give you a number. Maybe it gave you like 7 or 2.3. But when you take the derivative of it, this will be 0. And so you end up just getting sine of x to the 6th times 2x. That is f prime of x. And so it's useful. This second fundamental theorem of calculus is very useful because we can't actually find this antiderivative, but we know that if we plugged in x squared to it, we could take the derivative by using the chain rule. X squared would just get plugged in right here, and we'd have to multiply by the derivative of x squared. All right. I will do one more here. It says w of x is the integral from 1 to g of x of f of t. Find w of 3. So w prime of 3. So w prime of x is going to be, this is the antiderivative of f of t. We plug in g of t, so it's going to be w of g of x. It's going to be, I'm going to call it big F of g of x minus big F of 1, where big F is the antiderivative of f of t. So then when you take the derivative, it'll bring you back down to here. It'll be f of g of x will still have to be plugged into it by the chain rule, times the derivative of g of x, which is g prime of x. F of 1, of course, is a constant, so the derivative of a constant is 0. So w prime of 3 is f of g of 3 times g prime of 3. So we're just going to plug in 3 to g of x. That's 4. It says it in the table. G of 3 is 4. And then we're doing f of that, so f of 4, which is negative 1, times g prime of 3 is 2, and we get negative 2. All right, let's see. Ooh, I really like 12. 12 is a great one, and I want to make sure we all know what's going on here. So, 12 isn't a fundamental theorem question, though. I'm going to let you guys, well, no, I'm gonna make sure we know it. F of A is some negative number. We don't know what it is. There's no values here. But f of A is the y value here. This is f of A. Some negative number. F prime of A is the slope of the tangent line here. So it's going to be some positive number. F prime of C is the slope of the tangent line here. That's 0. F of D minus f of C. F of D